that we did what proportionalities. We started with like direct proportionality, and I told you, okay, two quantities are directly proportional when the graph between them straight line and is passing through origin, and the ratio between them is constant. Remember? And then we went to linear proportionality like this, like increase in temperature increases volume, but when the temperature is zero, volume is not zero. So I told you that this is the equation to explain that proportionality. And then we have inverse proportionality, like when we increase one quantity, the other decreases. And what happens? Okay, the product of the two quantities always remain constant, and the graph between them is a curve with negative decreasing gradient, right? So this is what we studied last time, and now we can go to some other examples as well. Like we know, students, that pressure is equal to force per unit area, right? So we can write it symbolically as like P equals to F by A. So then okay, pressure and area, they are inversely proportional if the force is constant. So pressure is inversely proportional to the area if force F is constant, right? And then from second law, we can also call it like A equals to F divided by M from second law of motion. So students, A and M are again inversely proportional. So A is inversely proportional to M if force is constant, right? So these are the things that are showing us the inverse proportionality. Now, negative gradient linear proportionality. It is actually like y equals to negative mx, right? Or I can give you an example, y equals to negative 2x, or simply y equals to negative x as well, right? So if we talk about this equation, plotting this equation, then this equation is going to look like this. If y-axis is like y and the x-axis is represented by x, then this equation is students y equals to negative 2x, where the gradient is what? Negative 2, right? And there must be some number here as well, because the y-intercept is also non-zero, so there must be some constant c with the y-axis as well. So this is called negative linear proportionality. So don't ever call it inverse proportionality. This is not inverse proportionality. Some people think it to be inverse proportionality, but it isn't, right? So it is not inverse proportionality. Okay, inverse of inverse. What is meant by inverse of inverse? Like the same thing we were studying yesterday, pressure was like 1, 2, 3, and 6. And volume was what? 6, 3, 2, and 1. And now I want to plot like 1 by V. 1 by V will be like 1 by 6 here. So it will be then 1 by 3. So it will be 1 by 2 and 1 by 1. 1 by 1 is simply 1. 1 by 2 is 0.5. 1 by 3 is 0.3. And 1 by 6 is what? It is 0.1 something. 1, 5. 1, 5? Oh, what happened to my calculator? Let me see. So 1 by 6 is like 0.16. Right, students? Now, if a quantity A is inversely proportional to the quantity B, then A is, okay, we'll see about it. Okay, now I'm going to take the product of P and 1 by B. P and 1 by V. P times 1 by V. So let's take the values. Like P was what? 1. 1 by V is what? 1 by 6. So it is 1 by 6. Okay, second reading. P is 2. Volume is 1 by 3. 1 by V is 1 by 3. So it is, what happened? Mhm. Okay, sorry, students. We don't have to take the product. We have to take the ratio between P and V, right? So let's say that we have to take the ratio P divided by 1 by V. Let's see what happens. Like P in the first reading is 1 and 1 by V is 1 by 6. So answer is what? 6. Okay. Now P is 2 here and 1 by V is 1 by 3. 3 will go up, so answer will be 6. P here is 3 and 1 by V is 1 by 2. So divided by 1 by 2, so answer is again 6. P is 6 and 1 by V is 1, so answer is 6. So you can see, students, the ratio of two quantities. What two quantities? The quantity P and the quantity 1 by V. The ratio of P and 1 by V. It is always remaining what? Constant. So tell me, students, when the ratio between two physical quantities was constant, they were called to be how proportional to one another? Yes. Bowling? When two quantities are like how proportional to one another, then their ratio is constant. Tell me. भूल गए हैं, कोई बोल नहीं रहा, आज क्या बात है? We studied yesterday कि distance over time की ratio अगर ले लें तो it was constant. So P और 1 over V की अगर ratio ले लें वो भी constant है. क्या था?
Inversely.
बहुत अच्छे. इतना टाइम लगाया और बताया भी गलत है. S was directly proportional to T. ठीक है, तो इसका मतलब P is also directly proportional to 1 over V. इसका मतलब P और V का ग्राफ हमने लास्ट टाइम ड्रॉ किया था, वो क्या आया था बच्चों? P और V का ग्राफ. This is the graph of P and V.
Sir, negative gradient
हाँ,
curve.
inversely
कर्व आ रहा था लेकिन नेगेटिव ग्रेडियंट.
क्या आ रहा था?
Negative gradient curve.
हाँ, इनवर्सली प्रोपोर्शनल भी हम उसे कह सकते हैं. क्या कह सकते हैं?
Inversely
अच्छा, P और V इनवर्सली प्रोपोर्शनल थे, तो P और 1 ओवर V क्या होंगे फिर? यानी इनवर्स ऑफ इनवर्स क्या हो जाएगा?
डायरेक्टली प्रोपोर्शनल.
प्रोपोर्शनल.
direct.
यानी P और V का ग्राफ अगर बच्चों ऐसे था, देखें, the graph between P and V was like this. Like this. So what about the graph between P and 1 over V? Like it is going to be like this, straight line. So they are directly proportional. Right? So what do we call here? P is, yes, inversely proportional to V. Inversely proportional to V. But what can I say, students? P is how proportional? P is how proportional to 1 over V? Tell me. Yes.
Directly.
Directly. This is what we studied new today, right? Okay, let's go further. Up, students, the next relationship, you won't find this relationship written in any book, but this is asked in exam. So be very, very careful in understanding it, right? Very, very careful. And if you don't understand anything, you just hold me right there and ask me to re-explain, okay? Students, what's the formula of kinetic energy? Yes.
Half mv
1
square.
over 2 mv square.
Yeah. So 1 by 2 mass into V square, right? Let's say mass is measured in kilograms. Speed is, let's say, measured in meters per second. So V square is measured in meter to S negative 2. And kinetic energy is, let's say, measured in joules, right?
सर आप कुछ लिख रहे हैं रुक गए हैं आप
I'm writing. You can't see? Abdurrahman? Yes, Abdul.
सर अब ठीक है, पहले वो जरा आई थिंक हैंग हो गया था हमारी साइड से.
Okay, okay. So, since let's say the mass of an object is fixed, let me say, let's say mass is 1 kg, right? Let's say it is fixed. And let's say speed is increasing from like 1 meters per second to 2 meters per second to 3 meters per second, and then let's say 4 meters per second, right? So the V square will be 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, right? So let's say the values of kinetic energy will be what? The value of the kinetic energy will be half mv square, and that is what? Half into mass is,
सर दोबारा एक्सप्लेन कर सकते हैं
yeah, the mass is fixed as 1, and the
सर
velocity is increasing from 1 to 2 to 3 and to 4 meters per second, right? So the
यस
square
सर
of velocity will be 1 square 1, 2 square 4, 3 square 9, 4 square 16, right? And then I'm putting the values in the formula, half into m into v square. So 0.5 joules is the value of kinetic energy in the first, half into mass into v square, that is 4, so 2 joules. And then half into mass into 9, so that is 4.5 joules. And then half into mass into v squared, that is 16, so 8 joules. So we got the data, students. Now we have to plot it, right? So plot what and what? Let's talk about it. We have to plot two graphs. So listen very carefully, right? Okay. So let us start with the first, second graph. Let me first draw the second graph. Kinetic energy versus V square. Right, so let me make it 115%. Okay, so let's say we have kinetic energy on the y-axis and v square on the x-axis. V square, right? So let's say this is like 1, 2, 3, or like instead of this, we can make it like 2, right? 4, and then let's say 6, and then we have 8, and then 12, oh sorry, 10, and 12, 14, and let's say somewhere here we have 16, right? So here is our x-axis, right? So Let me erase it. And let's say this is our x-axis, v square on the x-axis, and 16 is here. And the kinetic energy values are like, let's say, uh, 2, and we have 4, and then we have, let's say, 6, and then let's say 8. Kinetic energy is measured in joules, and velocity square is measured in m2s negative 2, right? So I'm gonna draw the graph. What do you think from the formula, students? What is the relation between kinetic energy and v square? Yes, what's the relation between kinetic energy and v square? Tell me. Direct or inverse?
Direct.
Direct. So the graph will be a straight line. So let me prove it. Like we know that kinetic energy is directly proportional to v square. This is what we know from the formula. Remember, it is v square, right? So let me see the values of, okay. So let's go back. 1 and 0.5, 4 and 2, okay. Kinetic energy is 0.5 when the velocity square is 1. So it is like, let's say this is 1, so this is 0.5, and here is our first point, right? And then when the velocity is 2, then the kinetic energy is what? 4 over 2 is 2. So here is our next point, right? And then we have when the velocity is 3, sorry, the next reading was like when the velocity square is 4, kinetic energy is 2. So velocity square is 4, the kinetic energy is 2. So here is the point, right? Here. And when the velocity square is 9, like here, the kinetic energy is what? 4.5. So here is 5. So here will be somewhere 4.5. So it will be like up to this point. Right? Okay. So here is our third point. Okay, now when the velocity square was 16, like here, then the kinetic energy was 8. So it's gonna be looking like this, and then this, right? So here we have the points. So if we join all these points, what do we get? Yes, students, if we join all these points, what are we getting?
Straight line.
Straight line.
Line, right? Okay. So now I'm gonna draw. We have seen the relation between kinetic energy and v square. Now I'm gonna plot the graph between kinetic energy and velocity. What is meant by this thing? Let's have a look. Right, so now our kinetic energy is gonna be on the y-axis, and v velocity is gonna be on the x-axis. Right, so let's say this velocity is 1, and then let's say 2, 3, and 4. Right, and kinetic energy values are like, let's say, this and this, 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 this. So let's say, students, Values are 2, 4, 6, and 8, and 10. So let's see what happens, right? Okay. So when the velocity was 0, kinetic energy was 0. So the first point is, students, simply the origin. Origin is our first point, right? And when the velocity was 1, kinetic energy was what? It was 0.5. So somewhere here is going to be the next point, right? And when the velocity was 2, kinetic energy was what? It was 2, right? So somewhere here is going to be the third point. And when the velocity was 3, kinetic energy was 4.5. 4.5 is somewhere like here, right, students? So our next point is going to be here. And when the velocity was 4, the kinetic energy was 8. So from here, let's say from here, the point is like here. Okay, students, so tell me, if I join all these points, am I getting a straight line?
No.
I'm not getting a
No.
straight line. I'm getting a curve. Like I'm getting a curve like this, students. This curve, whose gradient is increasing or decreasing?
Increasing.
Increasing. So gradient is increasing. Positive gradient is increasing. It is a curve with increasing positive gradient. So it's a really very important relationship. So what does it mean? Like we had the formula KE equals to half mv square. Okay, when we plotted the formula between the graph between kinetic energy and v square, we got the same relationship, like the direct proportionality, the graph straight line passing through origin. But when we are like plotting the graph between kinetic energy and we are not getting the same graph, rather we are getting a curve of positive increasing gradient. So what does it tell us? Okay, yes, kinetic energy was directly proportional to V square. Okay, we can say kinetic energy is directly proportional to V square. But what about here? We won't call it kinetic energy is directly proportional to V, because we will be now calling it kinetic energy is quadratically proportional to V. So this is what we are gonna say about it. Right, students? So this is some like next type of relationship that we just studied. So what does it tell us in simpler words? Okay, if we have exponent 2 in the formula and we plot exponent 1 in the graph, then the graph is always a curve. Graph is always a what?
Positive curve.
Positive gradient curve, right? So this is what we define as quadratic proportionality. If a variable a has a direct proportionality to the exponent 2 of the variable b, then a is quadratically proportional to the b. So this is very important relationship, right? Everyone got it? Yes?
Yes, sir.
Yes.
Okay, good. Is Josefa there in class or not? Josefa is not here, right? Okay, students, so we have this equation, an imaginary equation. A equals to, yeah, students. So my question is from you people, like A equals to y times c square over p. So A is how proportional to y? कौन बताएगा?
Directly.
Directly. Okay, I'm going to ask you one by one. Hamza told us first thing. Abdurrahman. A is how
Yes, sir.
proportional to c square?
Directly.
Directly. Maham. A is how proportional to c?
Inversely.
Ah, no. We just studied it.
Quadratic.
Quadratically, because we have exponent of c2 in the formula, and I'm talking about c, so it will be what? Quadratically proportional to c. Maham, got it?
Yes.
Okay. Sadiq. Sadiq, A is how proportional to P? Yes, Sadiq. Sadiq, where are you?
सर मैं बता दूं.
No. चलो हम पूछते हैं. किससे पूछें? Abdullah Jafri, yes.
Sir,
Huh? Yes, A is how proportional to P? Abdullah. Yes, Abdullah. Don't know, yeah.
directly, sir.
Directly, no. Yes, Umaima. A is how proportional to P?
Inversely.
Inversely proportional to P. Okay, Tamur, A is how proportional to 1 over P?
Sir, directly वो गलत दे दिया था पिछले का.
Correct. Right. Y is how proportional to C square? Yes, Abdullah Jafri. Y is how proportional to C square? Abdullah?
सर मैं
Well, you have
बता
to
दूं.
make Y the subject to the formula then. Make Y the subject to the formula and tell me what would be equal to. Yes, Abdullah. Abdullah,
Sir, पता.
P divided by C square. So Y is how proportional to C square? Yes, Abdullah. Maham, you can tell me y is how proportional to C square?
Inversely.
Inversely. Okay, Tamur, y is how proportional to P?
Sir, ये directly.
Very good, directly. This is what we are going to do in graph. Like if I'm talking about A and Y, they were directly proportional. So the graph is going to be straight line passing through origin. Straight line passing through origin. And if we are talking about like A and C square, they are again directly proportional. So A and C square graph is going to be straight line passing through origin. And what about A and C graph? Yes, Hamza, A and C graph. It is going to be what? A and C square graph is Hamza like this. So what about A and C?
So it's going to be, I think it's going to be a curve.
Curve.
It's
Negative
increasing gradient
Very good.
curve.
Okay, Abdurrahman, your question is like if A is inversely proportional to P. So if I draw the graph between like A and P, then it is
So
going to be looking like what?
negative Gradient.
Very
Curve.
good. Like, okay, Abdurrahman, same question from you. What about if I draw the graph between A and 1 over P then?
Straight line.
Very good. Okay. Umaima. Umaima, the question is from you. Like if you have seen that y is inversely proportional to c square. So I'm going to draw the graph between y and c square. Yes, Umaima, what would be the shape?
A straight line with a negative gradient.
No, not negative gradient. It is a curve with a negative gradient. Inverse proportionality, right? So we are done with the graph, students, and I have a question now. This question is from, who should I ask? I think Abdullah Jafri is gonna answer it. Yes, Abdullah.
Yes, sir.
What's the answer to this question?
Uh, Sir, B.
B. B for Bilal?
Yes, sir. Sir, B या A?
A तो नहीं है.
So C.
सर डी नहीं है
D कौन कह रहा है?
सर
मैं कौन? तैमूर?
जी सर
Very good. Taimur is right. D is the answer because आप देख ही नहीं रहे बच्चों क्या लिखा हुआ. It is
So
written
inverse.
I varies inversely as the square of the D. So I'll be writing it I is inversely proportional to the square of the D. So इसका मतलब ये है कि I और D square का अगर ग्राफ होता ना तो बच्चों वो तो फिर ऐसा आता. I and D square का graph would be looking like this. But what about I and 1 over D square? It would be straight line passing through origin. Inverse of inverse relationship, right? Everyone got it? Boys and girls?
Yes.
Yes.
Everyone? Okay, good. So let us go further. Okay, this question is gonna be done by you people. Yes, 31, and I'm waiting for your answer. Yes, students. Yes, students.
Sir, I
So
think
B.
answer A.
Bravo.
Okay. Yes, let's ask one by one. Yes, Abdurrahman is saying B. Hamza,
Sir, A.
Abdullah Jafri,
Sir, C.
C. A question has 3 answers. Oh, Maham.
So I'm gonna go with A.
Okay, Maham.
Yeah, A.
A. Umaima,
A.
Temur,
ए सर
Saad,
Sir, I don't know.
yes, Saad.
Sir, I don't know.
You don't know? You didn't understand the previous topic?
No, sir, I did, but I can't do this question.
Okay, Sadek, what do you say? I think Sadek just goes somewhere after signing in. And he's not listening to us at all, huh? Okay. So, yes, students, 80% of the class is right. And this I'm explaining it for you. The formula is T equals to 2 pi under root m by k. So, Sat, T is directly proportional to under root m, not m. So, if T is directly proportional to under root m, so it means if we draw the graph between T and square root m, then it will be a straight line passing through origin. Saad, am I right up till now or not? Tell me.
Yes, sir.
Okay, Saad. So, but there is no option like this, T versus square root m. So now what do? We think of another option, like we square both sides of this thing. So squaring this and squaring this. So what do we have? T squared, and it is proportional to what, Saad?
M.
M. So it is the same thing. T square is directly proportional to m. So if we draw the graph between T square and m, it is going to be again what? Straight line. So which is the given option? That is A, right? I got it?
Yes, sir.
Suresh, did I give you some assignment last time?
Sir.
Yes, sir. 25 questions dependent.
Yes, sir.
Acha, acha.
25 questions. Yes, sir.
Okay, no problem. So today I'm giving you, did I send you some workbook with answer sheet?
Yes, sir.
Yes, sir.
Okay, so should I give you some assignment for tomorrow or over the weekend?
Over the
Over,
weekend.
over the weekend.
Everyone agrees with that, huh? Okay. So let's do this question number 32. We have this f equals to ki square L by x. Determine the units of k. Let's make k the subject to the formula. Don't forget about it. It is going to be fx divided by I square L. Right? So f is what? kgms minus 2. And x is like length, meters, divided by current is ampere square, length is meter. So students, let's do the cancellation, like only meters cancel, everything else is there. So kg, m, s negative 2, and a will go up, it will also become negative 2. So this is the base units of k. Next question is, like we have the formula, f equals to ki squared L by x. So they are first asking about drawing the graph between f and x. What would be the shape of the graph? Abdurrahman?
Sir, आपकी आवाज कट रही है.
The question is, for using the formula, draw the graph between f and x.
Sir. Negative graph. Negative curve.
Negative gradient curve, very good. Okay, Maham, the next question is from you. What is the graph between f and I? Have a close look at the formula. F is equal to I square L divided by X. Yes, Maham.
Inversely.
Inverse. F equals to K.
So increasing gradient.
One minute.
Yes.
Yes, Mom.
It will be a curve.
Curve, quadratic relationship, right? So this. So there was like 1 mark for this in exam, CIE exam, and 2 marks for this. Right? Okay. So I think we're done with the topic and we're done with the time as well. I have to start my class as well, students. So, so I think it's time to say goodbye. Thank you, students. Allah Hafiz.